Hello, so in this video I'm gonna talk about common types of batteries that I think are crucial for electrical engineering. And I'm gonna talk about the chemistry of those batteries and their applications in electrical engineering. I'm gonna talk about various how these batteries are used in various electrical devices and stuff like that. So here there's an image. There's an image on the left side of the screen. You can see that's an image. It's an image showing the various chemical reactions that occur in batteries. So here this part it says chemical map. It's a map of different chemical reactions and stuff. And here's a second map. It says segmented chemical map. Right here on the very left top side of the screen, there's another graph. It's showing the amount of chemical reactions that are occurring in the batteries. And here on the bottom left side, it's like a chart, sort of like a bar graph. Here on the x-axis, it says the angles in degrees, and here on the y-axis, there's the number of voxel log scale. It's on like a logarithmic scale, and here it has different um, parts of the graph mentioned, like LFP rich. Here it says FP rich, and here it mentions mix of both LFP rich and FP rich. So, and here on the bottom right side of the screen, there's a showcase of a zinc carbon battery. I'm gonna discuss that later in the video, these types of batteries, but this is just like the layout of the battery, and it says construction of zinc carbon battery and mentions different parts of the battery and how it's made out. Like it mentions the positive terminal and negative terminal and the anode, cathode. There's also a metal jacket, insulation tube, and things like that. So here I'm going to talk about some of the foundations and basics first off about batteries. So batteries are electrical devices, and they're called electrochemical devices because they both deal with electrical energy and chemical energy. They make chemical reactions, and they also produce electrical energy. That's, as discussed before, why they're called electrochemical devices. They're used to power various things, various electrical devices. We'll discuss that a little more in depth later in the video. So yeah, and then this field of electrochemistry is very important to understand. That field that I'm referring to is the conversion between electrical and chemical energy. Okay. So in this video, I'll discuss two types of batteries. They're non-rechargeable batteries. These are also known as primary batteries, and then there's rechargeable batteries, which are also known as secondary batteries. And here I'll discuss the non-rechargeable batteries, or you could call them primary batteries. So these are batteries that they have to be discarded eventually at some point. Once they're used up completely, they must be discarded. And that's because they become depleted, and the reason that happens, depleted, that means they become used up. They finish eventually. They run out at some point, and the reason that happens is because as discussed earlier, there are chemical reactions that happen in batteries. Chemical reactions have reactants and products. And once the reactants are used up in the chemical reaction of the battery, the battery is finished at this point. The battery has been used up, it has been depleted, and at this point, these non-rechargeable batteries must be discarded. Okay. So I'll discuss a common type of non-rechargeable battery that's called the zinc carbon battery. And I mentioned this battery here earlier on in the video. So now I'll discuss this battery. So zinc carbon batteries are an example of non-rechargeable batteries. Okay, they have a zinc container. Okay, so they have batteries. Have an anode and a cathode. This battery's anode is the zinc container, and their cathode. So they, besides the zinc container, they also have like a carbon rod. So a rod of carbon material, and they have a paste of manganese oxide. So manganese oxide. And then the cathode also has zinc chloride. It also has ammonium chloride and carbon powder. This mixture of all these things together is the cathode of this battery. And now I'm going to discuss some of the electrical engineering uses of this battery. So this battery, the zinc carbon batteries, they're used for various devices that have low drain. And these would be things like flashlights, those kinds of devices that have low drain. Another like pretty beneficial property of this battery is that it has consistent voltage. It has a reliable, consistent source of voltage, and it's reliable in terms of voltage. So now I'll discuss the other type of batteries called the rechargeable batteries. And rechargeable batteries are the opposite of non-rechargeable batteries. These rechargeable batteries are also known as secondary batteries. You can call them that as well. Rechargeable batteries can be used over and over again. That's because the chemical reaction that occurs in these batteries, it can the reactants don't get used up. Well, yes, they do get used up, but they aren't depleted though. They can be used over and over again. It's a different type of chemical reaction. The reactants in this chemical reaction of these batteries is different than that of the non-rechargeable batteries. So I'll discuss solid-state batteries here. The interesting thing about solid-state batteries is that they use solid electrolyte. See, normally in batteries, most batteries, I should say, typically for the electrolyte, um, use various liquids. Sometimes they use gels. That's most common. Traditionally, batteries are made that way. But this solid state battery, they use a solid electrolyte. They don't use liquid. They don't use gels. They use solid instead. That's pretty interesting because it makes the battery function differently. And then in electrical engineering and kind of technology in general, they're used in various modern technologies, new devices, and new electrical, you know, machines and stuff. These would be things like EVs. Those are electrical vehicles. They can also be used in various next generation technology. 5G phones and stuff like that. Maybe even 6G phones as well. And the reason for that is because these batteries are considered to be very safe. They're considered to be safer than other batteries, such as the lithium ion battery here in this image. They also have higher density. That's pretty good because they can function better. They have better performance if they have higher density. They can also charge at a very fast pace. That's beneficial. They can charge faster than other batteries. They have like a faster rate of charging. That's pretty good. And they can operate at various temperatures. They can operate at hot conditions, cold environments, various degree ranges. They can operate in more intense environments, less intense environments. And that specifically refers to like temperature environments. So yeah. So that's it for this video. I hope you enjoyed, and if you did, make sure to leave a like and subscribe. See you in the next video.